Okay, I got interrupted halfway through the video here, so this is the second video on Chapter 3, starting at problem number 28. In this problem, we're adding two integer or fractions, and the fractions do not have a common denominator, so we first have to convert to common denominator. We can see here that we have a 6 and a 3 as our denominator. It's easy to see here that if we multiplied the 3 times 2, we'd get 6, and so we can rewrite that problem doing such. We got 5 over 6 plus 2 over 6, and we just add the numbers together, and we get 7 over 6, which is 1 and 1/6. The next problem, we have two mixed numbers. We have to switch those over to improper fractions, so 7 and 1/10. If you remember, we times and then add. So 10 times 7 is 70, plus 1 is 71. And for the second number, 2 3/4. We take 4 times 2, which is 8, plus 3 is 11. And then we put these over here in this problem. 71 over 10 minus 11 over 4. Now we have to find a common denominator because our denominators are different. And one way to do that is just do a multiplication table, or a factor table. Multiplication, so we do 10, we go 10, 20, 30, 40, and we do 4, 8, 12, 16, 20, and we see that 20 is the first number that appears on both sides, so we're going to change this to 20. To do so, we have to multiply 10 times 2, so we have to multiply 71 times 2, and to get the 4, it has to be multiplied times 5 to get to 20. So that's the multiplication there. And when we're done, we get 142 over 20 minus 55 over 20. And when we actually do that subtraction, I think we end up with 87 over 20, which is 4 7/20. And that was number 32. And the example in 32, well, that was number 31, excuse me. And the answer is 4 7/20. Yes, so I was just double checking that. That is correct. Now on 32, once again we have an equation we have to solve, and we notice that we have addition. So the opposite of addition is subtraction, so we need to subtract 7.8 from both sides. And when we do that, we're left with just y on this side. We have to line the decimal places up, borrow a number, 2, that makes that 3, 13 minus 7 is 6, and there is our final answer for number 32. Oh, excuse me, I did that wrong. Let's do that over. Hopefully you caught on right away what I meant, where I made the mistake. There we go, 14. There's the original problem. And we did everything right, minus 7.8. I just didn't see that minus sign. So when we go 7.8 here, if you remember correctly, we'll end up with y on this side. But when we have draw a better line there. When we have two numbers being negative numbers going together, right, you just add them together and use the sign. So we're going to have a negative 21.8, and that is the correct answer. Now we have number 35. We got 3/8 p equals 3/4. And if you remember, there's a special rule for that. You're just going to multiply. You look for the coefficient here. This is the coefficient of your variable. We're going to reciprocal and multiply both sides by that reciprocal. So there's my parentheses. I reciprocal the number. And if you really think about it, look what the reciprocal does. The reciprocal cross cancels to 1, everything to 1. And you're just left with p on this side. And then on the other side, we can cross cancel 1, 1, 1, 2. And that leaves us with a final answer of 2. Now 36. On number 36, I think we're supposed to graph it, are we? Nope, just solve it. Just solve number 36. So we look at the problem again, and we see that we have a multiplication problem. Let's change that color. This is a multiplication problem. The opposite of multiplication is division. Okay, so we are going to divide by the coefficient 4, and we're going to divide this whole thing by 4. Let's just call it 4/1. So it's a fraction. On the left-hand side, we're left with just m. We still have the greater than sign. And now, on the left-hand side, or the right-hand side, we got 1/3 divided by 4/1. And if you remember, when you do a divide fraction, you change the division to multiplication and you invert. And so this line here became our multiplication, and there's the inverse of 4/1 is 1/4. And now you don't have to worry about these numbers, and when you multiply it out, you get a negative 1/12. And that's our answer. All right, let's look at number 39 now. Number 39 is the same type of problem that we just did, except it's not multiplication, it is addition. So the opposite of addition is subtraction. So we're going to subtract 4/5 from both sides. And on the left-hand side, we're left with just our x. Bring down our greater than sign. And now, on the right-hand side, we do not have common denominators. But we do know that 5 times 2 is 10, and that'll get us a common denominator. So we're going to rewrite that 3/10 minus 8/10. And if you remember your rules, if we have a opposite sign, so we have a plus and a minus, we take the big number minus the little number and use the sign of the big. Well, the sign of the big number is negative. That's 8. So we take the big number, 8 minus 3. That gives us 5, and we're going to use that sign, which is negative. So we end up with, this equals a negative 5/10, which is equal to a negative 1/2, and that's our answer down here. And that's number 39. Now find the two square roots, number 40 of 16. Well, if you remember correctly, when they ask you for the 2 square roots, all they're saying is what is the square root of 16? Well, we know that 4 times 4 equals 16, so the square root of 16 is 4, and we could have made it negative 4 times the negative 4 also equals 16, so the answer to this problem is just plus or minus 4. Number 44, we need to evaluate, so we're going to evaluate the square root of 100 is 10 times 10 is 100. So the square root of 100 is just one of those numbers. So we'll write that out. It's 10 over 20 is equal to 1/2. Now, the last three are just deciding if it's rational, irrational, or not a real number. Let's remember that rational numbers are repeating decimals or ending decimals, decimals that end, or any kind of integer or whole number or anything like that. Whereas irrational numbers are any numbers that never repeat and never end. And finally, so let's take a look at the first one. This is square root of 81. 9 times 9 is equal to 81. So this is the square root of a perfect square. And if you remember your rules, whenever you're taking the square root of a perfect square, that's going to give you an integer. And an integer is a rational number. So that's the answer to that one. Opposite of that is if 122, is that a perfect square? Well, 11 times 11 is equal to 121, and 12 times 12 is equal to 144. So that is not a perfect square. So the square root of not a perfect square is by definition an irrational number. So that's the answer to that one. And finally, this last one, we have a square root sign and we have a negative on the inside. You can't take two numbers that are negative, two numbers multiplied to each other, and get a negative answer. So no matter what you do, you can't find an answer to this guy as long as there's a negative on the inside of the square root. So this guy ends up being not a real number. And that's the end of that.